Hello and welcome to another JASP tutorial. This one is going to be covering linear regression, and so I have, as you can see, a pretty big data set that has lots of different columns, so lots of potential variables that I can use, and also many different participants. So I have 395 participants here, and let's say that I want to look for specific predictive patterns in the relationships that we have here. The way to do that in JASP, there's several different ways to do it, but one that we're going to look at is with regression. So if you click on regression right here, you'll notice that it gives you a couple of different options. So we're really going to be focusing on linear regression right here. Correlation is just if you're looking at whether or not two variables are related. Logistic regression is if your dependent variable is binary. So if your dependent variable is like win or lose, or yes or no, then you would use a logistic regression, but it's a little bit more complicated than a linear regression. We're just going to focus on linear regression for now. So if you click on that, it gives you a very familiar interface, and so you'll note that this looks a lot like an ANOVA, right? And that's because largely, for the most part, the math that's going on for a regression under the hood is basically the same as an ANOVA with a linear regression. So if you have one predictor variable, which is what we're only going to focus on here. We're just going to focus really on one predictor variable. So a quick little bit about this data. What I'm going to be doing is I'm ultimately interested in GPA, which is this final column right here, and I'm interested in whether or not any of these other variables are predictive of that. So let's get into it. So I am going to, because I'm interested in looking at what can predict GPA, I'm going to move down and I'm going to put GPA in the dependent variable section. So you'll see that I have that right there. Now, the next thing that I want to do is I want to pick a variable that I have a good hypothesis for that might predict this variable. So, for example, maybe it's absences. Maybe I suspect that absences significantly predict someone's GPA. That makes sense. So I'm going to enter that into my model here. And so what you're looking at here, you're looking at let's start with the ANOVA section right here. So the ANOVA section right here, this is assuming the model. So the model, basically the whole, like y equals a plus bx, right? So whereas the b there is going to be the slope that is contributed by absences. And what you can see here is that p is greater than 0.05. So in other words, this is not a significantly predictive model, that our slope is not significantly different than 0, basically. So that model is not super helpful, right? So we are going to put that one back in the pile. And I am thinking, what else could contribute to this? Oh, failures. Failures should obviously contribute to GPA, right? The idea being that if somebody has more Fs, that they're going to have a lower GPA. So let's just double check, make sure that that's true. And so I'm looking at my ANOVA here, and I can see that my ANOVA is indeed less than 0.05, which means that my slope here is going to be significantly different than 0. So that means that my model does have some predictive value, and so that's what the ANOVA section right here is. Now if I want to, I can come over and I can look at the coefficients section. Now the coefficients section is where I want to go to really kind of understand the equation, like the line of best fit. You can find that here. And where you find it here is ultimately going to be where it says H1. So this is our alternative hypothesis. And it is going to tell you the intercept, and it is going to tell you the slope that is provided by that specific variable. So if we were writing this out, this would basically be y equals, and then our intercept value, which is 2.789. So assuming that you have 0 failures, you should have a GPA of roughly 2.789 on average. Now, the failures unstandardized coefficient. This is going to tell you your slope. And so our slope here is negative 0.555, which basically means that with every increasing value to the failure rate, that is going to drop GPA by negative 0.555 on average. In other words, if you have zero Fs, then your GPA might be 2.789, and compared to someone who has 1 F, their GPA on average is going to be roughly 2.234, right? Because we're subtracting that, we're moving away from that. And then if we were to look at 2 Fs, then we would just multiply 2 by this coefficient and add that to our intercept. So that's basically how you can find the line of best fit using JASP. So that's where that is. You'll note that here it has independent t-values, or I should say separate t-values here. They're both less than 0.05. This would be like if you're planning on adding in additional values. So like let's say I added absences to this model. So now I actually have two coefficients that I'm looking at. 2 predictors. I can see that this one particular variable does not seem to be predictive because it is not less than 0.05, just to give you an idea. Let's see. Now, sometimes whenever you're working with your data, if you are playing around, you might find some unusual findings. So, for example, if I plug in age right here, I find that is actually predictive of GPA. So I can see that according to my ANOVA, that yes, it is less than 0.05, which means that my model is predictive. It means my slope is not equal to 0. And is it positive or is it negative? If I go down to my coefficients, I can see that it is negative. So in other words, that this is a negative slope. The older you are, the lower your GPA gets. Those seniors out there know exactly what I mean. So that's basically what that is representing there. Okay, so basically, if somebody was 10 years old, which that wouldn't be possible, but if somebody would, let's say somebody's 20 years old, you would just multiply this value by 20 and then add that to our unstandardized coefficient. Yeah, so that is basically the coefficient side of things. If you wanted to, you can play around with the model. So if you added in multiple coefficients, you can change those terms here. You can also look at different statistics. You'll note that when I'm looking at the coefficients here, that I have unstandardized, which is what I've been using, but I also have standard error, and that is because each of these estimates also has its own variability. So the standard error for the y-intercept, the standard error for the age coefficient, things like that. So you can see how much variability, how much wiggle room you have there. You can see descriptives, so looking at the mean GPA and the mean age for this data set. You can find confidence intervals, which can be helpful if you're looking for variability in these, which typically you don't do too much at an undergraduate level. Let's see, what else do I want to look at? If you want to plot things out, which can be really nice, and I actually really love this right here. This is the residuals versus the residuals versus the dependent. And basically what that means is that, well, actually, hold on. Let me show you the residuals versus the predicted first. So this is looking at the residuals versus what we predict. So we are predicting the values based on our line of best fit, and you can see how well that lines up with how accurate it is. If it is completely accurate, it'll fall right here on the 0 line because all of them are right there on the line of best fit. But you can see here there's lots of variability, so you're going to have some values that are going to be much higher and much lower. So it's just a way of showing you how accurate your particular line of best fit is. And you can do the same thing with residuals versus dependent, where here you're looking at residuals and you're looking at GPA. So instead of looking at the predicted value, you're looking at the actual values here. Some people like to look at the QQ plots. The QQ plots is to basically look at how well or how normal your data is. If this is really skewed, then you should be worried. But that's kind of a different subject to talk about. Yeah, so that's pretty much it. So that is a quick run through of linear regression in JASP. Pretty straightforward, at least to me, much more straightforward than other statistical programs. Thanks for watching. Bye.